Hi, welcome back to Make Cool Stuff. I'm going to start this video with a warning for anybody who wants to start tuning their car, or certainly supercharging their car. And the reason I'm out here with the car and the hood's open is this engine will need to be replaced. I had to start troubleshooting it. By the way, it's really hot out here. I had to start troubleshooting it when I found an injector was intermittently going on and off. The car wasn't making very much power. So I started troubleshooting it. I went through the harness. I thought it might have been a broken wire for an injector because I've had that problem before, but you know, it was so intermittently even on and off. It would pulse for 15 seconds, go off for 5 seconds, and just repeat that kind of thing. And occasionally the car would even make a little power here and there. So anyway, when it got right down to it, after doing a little research online, I found out that the only code I was getting, check engine light code, was a misfire code on the number 4 cylinder. So I went online and I found it was a Ford F-150 site was talking about the computer, if it senses a misfire, will shut down the injector, presumably to stop cylinder wash and to stop backfiring, that kind of thing. However, it doesn't really give you any kind of indication what exactly the problem is. So from that point, I pulled out a spark plug, and I will insert the picture here of the spark plug. Yes, the electrodes were pushed together, and there was a few little marks on the electrodes as well. So from there, I was like, okay, well, something hit that spark plug and something closed the electrode. Oh, this doesn't look good. I borrowed a buddy's borescope, went in there and had a look, and sure enough, I've cracked a piston. So I'm starting this video off with a warning to you about what happens with supercharged cars, in particular supercharged cars with stock rotating assemblies, which is what I've got. This is just a stock Crown Vic engine in here, so they're not just pure cast pistons. They're called hypereutectic pistons, if I've pronounced that correctly, and they're not bad, but they don't like boost, despite what you might hear on the internet. They don't like it. So we'll talk about that further, but anyway, we'll get into the tuning part of the video right now. Thanks. So broadly speaking, modern fuel injected engines work like this. There'll be a throttle position sensor on your throttle body, and based on what it says, it will be giving instructions to the engine as to whether you want the engine RPM to go up or down. And it can also control your transmission. In the case of a Crown Vic, for sure that's what it does with an automatic transmission. It might kick it up, kick the up a gear or down a gear. It will look at the engine RPM and the mass air flow meter, and it'll come up with targeted values based on different parameters that are set in the software, as well as different tables, to come up with a targeted air-fuel ratio and spark advance. It will read the exhaust via the oxygen sensor to see if it's actually if the burn is complete as it wants it to be, and adjust the mix up or down. It will also look at your engine temperature sensor, your NOx sensor, and your air charge temperature sensor to adjust your spark advance up or down, as well, in some cases, the air-fuel ratio as well. So it kind of works like, if obviously a NOx sensor, it's going to knock the timing back a little bit, or a lot, maybe, depending on how bad it is. Air charge temperature sensor, it's going to work like a choke on a carburetor, in that it will richen the mixture if need be, and knock the spark advance up or down depending on what's required. So broadly speaking, that's how they work. So if we're talking about tuning for boost, broadly speaking, what you will be wanting to do with your tune is, broadly speaking, reduce the spark advance by quite a lot. You will also want to enrichen the mixture, and by that I mean your car will be operating anywhere between being on boost and being not on boost. If you're just idling around town or whatever, it's probably not going to be seeing any boost at all. But certainly on boost at wide open throttle, you're going to probably want to add about a full point to the air-fuel ratio. So if a normal amount of air-fuel ratio for wide open throttle would be, say, 12.5 to 1 fuel to air, you're going to want that to be maybe around 11.5 to 1 for a turbocharged or a supercharged application. So the other thing that is required when you're tuning a car is you'll want to expand all the check engine light code and tuning thresholds so that the thing isn't constantly going to limp mode, and that's what tends to happen when you're tuning your car for the first time, or even as you get into it, you'll keep bumping up into the limits, the thresholds that trigger different check engine light codes, and certainly you can sometimes just shut the whole code right off, just disable the code, or certainly with in a lot of cases, just for the different parameters, you have to just expand them. I mean, the engine sees, they talk about engine load. So engine load would be what the engine expects to see with a naturally aspirated engine. The number will be 1. So that would be, they would look at the amount of air that the size of that engine can pull in under normally aspirated conditions. And if you start, say, boosting it by, let's call it, 7-8 pounds or something like that, well, it's going to be seeing probably a load value of something like 1.4, something like that. So that would be typical of the kind of things you have to do, and that's just so that the engine computer knows to look at what numbers are acceptable and what numbers aren't acceptable. So that's broadly speaking what you're doing when you're retuning your car. So when we're talking about tuning your car, the different ways of tuning your car will come down to these 4 different ways that you see on this slide here. The simplest and most, well, I won't say it's the most common way, but the simplest one would be if you buy yourself a flash programmer. They will give you some very simple ways of adjusting the tune in your car. And certainly for a Crown Vic, once again, I'm not an expert, but for a Crown Vic, they were very limited. They would give you tunes that were optimized for different octane ratings of gasoline, commonly available street pump gas, and they would be optimized for naturally aspirated engines. It would only be stock engines in the case of the Crown Vic, and it would be optimized for 87 octane or 93 octane, and it would adjust the fuel maps and the spark advance maps to be a little bit better than stock. You won't see huge improvements, but you'll see some. It would be worth investigating that just to see what kind of horsepower levels you would see. I mean, I played around with this quite a bit with an older Crown Vic I had, and it's not a huge difference. There is a difference, but it's not huge. Don't expect to see big power gains there. What it's also useful for is you change the rear end gears in your car. It'll give you the capability of going there and adjusting that the numbers in your engine computer so that your shift points will all be corrected for the new rear end diff ratio, as well as your speedometer will read correctly. Things like that. If you change the tire size going up or down, you can adjust that as well. Once again, it'd be adjusting the shift points and also adjusting the speedometer readings. It will also allow you to change on a Crown Vic the shift pressure. So and by doing that, you'll get a quicker, punchier shift, which is a good thing for a performance car. A standard Crown Vic was optimized for soft, sluggish, not very intrusive shifting from the transmission. So it was soft and people didn't really notice it. So, but for a performance car, you want it to knock itself into gear as quickly as possible. So that's what you'll see from a handheld flash programmer. From there, you would go and you would see a little more elaborate tuning possibilities, or quite elaborate tuning possibilities, depending on who the vendor is. And there'll be guys on the internet who will tune your car by email. You just tell them what you've got. Oh, I put headers on my car, long tube headers. I've got a camshaft with this much duration, and they will certainly with a Crown Vic or the way Ford does it. is you'll give them the VIN number of the car. From there, they will get something called a strategy for the engine, which is really it's the specific program for your car. Now with the handheld flash programmer, that's all internal between you plugging the flash programmer into the OBD2 port and the flash programmer itself. So it handles that internally. But if you're talking about with email, it's going to, the vendor who's selling you the tune is going to have to go back to the tuning company and get the strategy for that engine computer specific to your car. And this can be a real problem with, funny, it's not a problem with police interceptors because they don't have security systems on them. So this is, I think, one of the main reasons you have to give them the specific strategy is because it has to, when they tune your car, the engine computer has also got the security features that you'll see for your specific car. So there can, in some cases, it's a chip in the key, and anyway, I won't go into it, but that's what they need to do. So they'll take that, and you'll tell them, well, I've got headers, I've got a camshaft with this much duration, I want shift points, this, and they'll come up with a tune for you. There probably won't be a lot of back and forth between you and the online tuning company. You might say, well, the engine's doing this or it's doing that, and they'll adjust it for you and send you a new tune, that kind of thing. I've had some success with that, and some, basically some bad tunes that really didn't work out for me as well. But yeah, it can work out. Certainly, if you start putting bolt-on modifications to your engine, it's not a bad way to do it, especially if they're sort of typical engine modifications. So that's something to look at. And then from there, you would go to the next step up from that would be a remote tune. And I've done that as well. And there you will be, once again, you'll tell the guy doing the tuning remotely what this is really. It's a remote tune, so he's somewhere off in the world somewhere away from you, and he is going to once again get the strategy for the engine and take into account the modifications. But from there, he's going to ask you to start data logging your vehicle. And I'll talk about data logging in a minute. But from there, he's going to be getting specific data points from your car. So you'll run data logging software with a laptop in your car, and you'll drive it around under certain conditions. Send that back to the guy who's doing the remote tune. He will make adjustments to your tune. Once again, you'll go out and data log the car again, as many times as it takes to get the car running right. And I've done that as well. I didn't have good results with it, but anyway, I'm not saying it won't work. From there, the next step up from that, and this would be probably the gold standard, would be a dyno tune. And that you're taking your car to a dyno shop, and he will have the person doing the tuning will have access to the same kind of software that that you would have for tuning at home, but a better version of it, a more in-depth version. And he'll have access to a lot of different data files that you won't have access to, which will start him. It'll be a good starting point for his tune. So in the case of, say, my supercharger, he could probably find a similar supercharger for a Crown Vic or a Mustang or a Ford F-150 or something like that, and start there. Plug in the they call them value files with SET. And then from there, he'll start running the car on the dyno, and he'll be data logging while he's doing it. And from there, he'll adjust the tune up or down, and he'll do it probably over a period of 4 or 5 hours, something like that. Now, it can be very expensive. So dyno time's not cheap, but it's like, I don't know, $150, $175 an hour or something like that. So you're talking 4 or 5 hours at that price, but you'll walk away after 4 or 5 hours with a car that is hopefully optimized to run correctly, and it will give you maximum power, or he'll give you what you want in that case, whether it's a really safe tune or a really extreme tune for drag racing or something like that. So that is kind of what the different tuning options for your vehicle. Okay, so regarding flash programmers, you are going to need one no matter what to be able to install any tune onto any vehicle. And you'll, in the case of engine tuners, they will sell you one that's probably very specific for a Ford or a General Motors or a Chrysler or an Audi or whatever. And it is specific to that vehicle, and in case, certainly with the case of SET, it's married to the vehicle. So when you install a tune, it actually pulls the stock tune off the engine computer, saves it on the flash programmer, so you can reinstall it later if need be, and installs the tune for you. So for any kind of tuning, you'll at the bare minimum you'll need one of these things. So you can pick them up secondhand. What you have to watch out for is whether it. As I say, I'm not an expert. I don't know how any of them work, with the exception of the SCT one that I own. And with the SCT one, it will give you 5 marries. So in other words, you can marry it to 5 different vehicles, and after that, it runs out of marries, and you would have to go back to SCT and get them to unlock the thing for a fee, and you could do additional vehicles after that. But when you buy the thing, it's capable of doing 5 different vehicles. So now I just went online and I found just a list of different aftermarket tuners of what's out there, and I really just went on to a specific speed shop website and looked at what they had for sale, and this is what they had. So that's just a quick list of what I was able to find. So as I say, not all vendors are covered by aftermarket tuners, and it's something, if you're planning on making mods to your car, you got to find this out up front, because some of them simply aren't. Some of them simply have not been cracked by the tuning community to allow you to go in there and change the tune, or the vendor made it so difficult that it wasn't worth a while to offer a product that would do that. But yeah, most of them are out there, and you should have luck finding something if you're on this list here. So a few things you want to look at via data logging, if you're doing it that way, and you're trying to program the car yourself, is a few values that you need to look at to make sure you don't hurt your engine. Is you want to make sure your mass airflow meter doesn't peg. In other words, it doesn't run out of headroom in other words, it can't read the amount of air that you're pushing through, the additional amount of air after performance modifications that it is seeing. So if it runs out, if it's typically with the Ford, if it gets to the point where it has reached its maximum number, in the case of Ford, it's called counts. It does something called pegging, which it means it won't read any higher than, I think it's 1,024 counts. And past that, it's not going to read any additional air that it's seeing. So as the engine RPM goes up, your air-fuel ratio will start to lean out, which could be a really bad thing. The other thing you want to look at is your fuel pump duty cycle. If it starts to get too high, and I don't want to go on the record for saying exactly what too high is, but you want to have lots of margin there on your fuel pump duty cycle. Once again, if your fuel pump can't manage it, the amount of fuel going through, or it can also be fuel lines too, but it's probably going to be mostly a fuel pump problem. And the same with fuel injectors. If they can't handle the amount of fuel that's being asked of them to deliver, or if you're getting really, really high in the duty cycle, you'll want to go online and find out exactly what those numbers are. It could be 75-80%, 75-85% of your duty cycle. Once you hit that number, it's getting too close to 100% to guarantee that you're not going to start to see failures. And if you see a failure there, you'll get a lean condition, and you'll end up with an engine like mine with a cracked piston, or hopefully not, but that can happen. So that's something to look out for if you're doing the tuning yourself. So I've got a slide here showing my 2 different flash programmers that I've got. Once again, I've got several Crown Vics in the driveway, so you need one programmer for each car. So I've got the first one I got was the Livewire one, and I mean, both programmers will install tunes for you, and they do exactly the same thing, with the exception of the Livewire one will also has some performance features on it that'll allow you to do 0 to 60 runs on the car, which I think is pretty common. I think there's cell phone applications that do this as well now, but yeah, it's kind of a fun feature. So I like that. It will also do live data logging, if you will. You can. It's also it's a touch screen. It's just a little a somewhat more advanced version of the simpler version you see to the left there. So touch programming and the 0 to 60 feature, or quarter mile feature for that matter, and it'll let you do, as I say, live action. It's like a series of gauges that you can pull up, and they give you different styles of screens, and you can monitor your air fuel ratio live, or different your mass airflow meter, or different things like that, or a whole bunch of them at the same time, even for that matter. So it's kind of a cool thing to have. I like that one. Now, what I did find I had a problem with the live wire one was it wouldn't, when you get to the data logging part of it, it wouldn't accept the signal coming from my air fuel ratio gauge. So I couldn't do data. I couldn't do full data logging, including my wideband air fuel ratio gauge. So that's a problem. That was a problem. That's why I ended up having to unmarry the live wire one with a supercharged car and use the simpler one to the left there, because the data logging feature worked for the air fuel ratio gauge. Okay, so if you want to go down the path of tuning the vehicle yourself, like I did, this is kind of what you can expect to see from the software that you'll use to tune the car. This is SCT Advantage software. In the case of this was kind of the version of the software that gave you maximum access for private individuals like myself. But this is all changed. SCT went through a lawsuit, and I think they now limit, or they now put strong limits on who gets the software that gives you full access to the programming. And really, with the simpler version, I couldn't even do what I needed to do. Even for like just adjusting for long tube headers, it wasn't possible. I didn't have access to the parameters required to make the changes. So the guy on the phone just gave me full access, update my software. But I don't think that's the case necessarily anymore. They want you to either take a course, or I don't even know. I kind of stopped looking at it at that point. My car was tuned, and I just left it at that. So, but this is kind of what you can expect to see. There'll be multiple tables in there that map out load to RPM and target air fuel ratios, or target spark tables. In the case of the one here, this is a borderline knock table, and that's kind of like maximum spark advance that the engine might see. And you can see, like in this particular slide, the red values are all the ones I changed when I was tuning the car. So that's kind of, there's an enormous number of parameters that you can adjust in these things. It's scary how many there are. So if this doesn't put you off doing it, I can tell you there are thousands of parameters you have access to. So as well as many numbers of these tables. There's maybe only 3 or 4 tables that are important, but there's quite a few of them in there. In the case of the SCT software, they will give you some guidance on what you need to do. Say for a supercharged application, they'll say, well, you really want to change this value here, this parameter here, that kind of thing. But you really do have to hunt for it. It's not, I haven't taken a course, so I really had to hunt and peck for all these values to find them. And certainly in the case of my broken engine out there, I went a little too aggressive on the spark advance. Now, to be fair, I used a spark advance that was, I mean, my engine in that car is more or less a recipe that I got out of a book by a very knowledgeable industry expert on a Ford 4.6s, and my engine's identical to one of the engines in his book, and I used spark advance values that he used, but his values were for a dyno engine, looking for maximum power. So clearly that was a little too aggressive, and I shouldn't have put quite so much spark advance in there. I'm assuming my cracked piston came as a result of knocking at high RPM and high power levels. So something to be concerned about when you're thinking about whether you want to supercharge your car or not. So let's look at a few other tables here. So yeah, there's as I said, an enormous number of parameters, and what you can also do with the software is you can shut off different check engine light codes. If you're getting them all the time and you know what they are, and they're not really, it's sort of saying, well, you're exceeding a power level, or you're doing this, you're doing that, whatever the code may be, and you just want to shut the damn thing off so it doesn't keep triggering the check engine light all the time. You can just disable it in many cases. So there's a lot of things you can disable, and that's probably why SCT got in trouble with their software. So and the way SCT goes about allowing you to make sort of broad changes to your engine tune is they have something called value files. And I think what these things are is they're algorithms that go in there and take your engine tune. It will apply it to the strategy that you have purchased from SCT, and it will, in the case of the one here you see on the screen in front of you, it's got 4.6 two valve PI heads, blown 91 octane. So it will apply a certain number of algorithms to a lot of these tables and different parameters in the software, and just make the changes, boom, just like that. Now they're not going to be optimized changes, but they're going to get the car at least to the point where it will run. You'll have to go in there. They won't be aggressive, an aggressive tune that you'll be loading up there. But as I say, the car will run probably. It'll get you started. And certainly you can look at what the changes they've made. You can do. They have a compare feature where you can compare the stock tune to the tune that you're working on, or any tune that you happen to have on your laptop. And it will compare the numbers, and you can sort of see where the changes were made. And this is useful when you're seeing, well, what did SCT want to change on this, and where would I need to make further changes, so to speak, to further optimize the tune. What else have we got here? I've got a base fuel table. So the numbers you see there, those 0.8 or 0.9 or whatever values, those are lambda values. Lambda is a number based on the fuel that you're running that it uses for setting your air-fuel ratio, and it's a different value for every different fuel. And when you're talking about the different alcohol gasoline mixes that you get there, the lambda value, it changes with every different mix of alcohol gasoline you've got there. So it's something you have to take into account when you're tuning your engine. So what fuel it is you plan to run, and you'll run into problems if you start running. Say if you've optimized your engine tune for to give you an extreme for E85, and you try to run gasoline on it, well, it's probably not going to run, or it may run very badly. Probably go into limp mode and leave the car nearly undrivable. So once again, I am not an expert, so anything I've got in here is subject to just my interpretation of where I'm at with tuning my car. I'm not someone who's done this a whole lot of times, but this is what I discovered along the way, and it's something it's good information for you if you're thinking about either just changing the tune on your car, or making mechanical changes to your engine that will require retuning as well. So anyway, I hope you've enjoyed the video and found it useful. If so, please like and subscribe. I would really appreciate subscriptions, if you will. I will do some. I'll have additional engine performance videos coming down the line. In particular, I'm getting a lot of questions from different viewers about whether I think a particular a particular car and engine would be a good idea to supercharge it. What size Eaton supercharger would I recommend, that kind of thing. So I'm going to do a video talking about performance mods on vehicles, and whether supercharging is necessarily a good idea, and what you're going to need to want to look at if that's the case. And certainly, even if it makes good financial sense, it doesn't always. And certainly, if you have to take into account that you might break the engine, that's something you definitely want to think about. If you're not handy, a broken engine's a big deal. With my engine, I am now looking at, I've been sourcing a shop to do the work, and I think it's going to cost me, I'm going to do an engine, I think it'll be a rebuilt engine using the engine that's in the car now. Stock block, stock crank, forged pistons and rods. They'll have to balance the crank because of that. And all told, I think we're talking or at least $3,000 Canadian to do that work. And that's with me doing pulling the engine out and reinstalling it later, and probably doing most of the assembly work on the engine as well. So anyway, yeah, it's not a small amount of money. So anyway, thanks again for watching.